Have you ever wondered what really gives modern diesel trucks their incredible power, but also their surprisingly good fuel efficiency and cleaner emissions? Well, the secret isn't just about a bigger engine. It's about the absolutely mind-bendingly precise control of immense fuel pressure. Today, we're diving deep into the heart of that system, the common rail. This quote, it just nails it. It's the core idea that's been pushing diesel tech forward for years. See, more pressure isn't just about brute force. It's about being smarter, faster, and way, way cleaner. I mean, it sounds impossible, right? Usually in engineering, you've got to trade one of those for the other. But in the world of modern diesels, you really can have it all. And the answer to how? Well, it all comes down to how these systems have totally mastered fuel pressure. All right, so let's pull back the curtain and look at the technology that makes all this happen. It's a huge shift in how a diesel engine even thinks about getting its fuel. Okay, so in the old days, the pump had to build up pressure for every single injection. It was all tied directly to how fast the engine was spinning. But the common rail, its big breakthrough was creating this constant, high-pressure reserve of fuel that's just ready to go at all times. This gives the engine's brain, the ECU, complete and total control over when and exactly how that fuel gets injected. So what exactly is this common rail that the whole system is named after? Let's break down the actual parts that make this incredible technology a reality. The easiest way to think about it is like a high-pressure water tank for a big building. The pump's only job is to keep that tank, our rail, at a very specific pressure. That way, every single faucet, or in our case, every single injector, gets the exact same powerful flow the instant the ECU tells it to open. And here's the team that gets the job done. You've got the high-pressure pump, that's the muscle, creating insane pressures, sometimes over 25,000 psi. The rail is what stores all that energy. The pressure sensor, that's the nervous system feeding real-time info back to the ECU. And the ECU, well, that's the brain, making thousands of decisions every single second to tell the injectors what to do. It's just a perfectly integrated system. Okay, now this is where things get really clever. The ECU has two main tricks up its sleeve for managing these insane pressures, and each one has its pros and cons. So what we're looking at here is a classic engineering trade-off. The first way, the spill method, is kind of like driving with one foot on the gas and the other on the brake to control your speed. It's super responsive, but man, it wastes a ton of energy and creates a lot of heat. The newer, metering method is way more elegant. It's like using the accelerator precisely, only pressurizing the exact amount of fuel you need. It's super efficient, but it can be a little slower to react. So what do the engineers do on modern trucks? They use both. You get the best of both worlds. The super efficient metering valve does most of the work when you're just cruising down the highway. But when you suddenly lift off the gas and the ECU needs to dump pressure like right now, it uses that super fast-acting spill valve. It gives you efficiency when you need it and lightning-fast response when you demand. So having these control methods is one thing, but using them with incredible microscopic precision is what really unlocks the true potential of the modern diesel engine. And this shows you the constant conversation the engine is having with itself. The ECU sets a goal, the sensor reports back on the reality of the situation, and the ECU instantly makes a correction. This whole feedback loop is happening hundreds, maybe even thousands of times every single second, letting the engine adapt instantly to whatever you're doing with your right foot. This chart just visualizes that adaptability perfectly. When you're sitting at a stoplight, the ECU drops the pressure way down to save fuel and keep the engine quiet. When you're cruising, it's in a happy medium. But the second you put your foot to the floor, bam, the pressure skyrockets to over 25,000 psi to give you every ounce of power. And why is that high pressure so critical? It's all about something called the injection window. There is a perfect, tiny little moment in the engine cycle when injecting fuel is the most effective. High pressure is like using a fire hose instead of a garden hose. It can spray the same amount of fuel in a much shorter time, making sure the entire spray happens inside that perfect window. And that means you get a much more complete and efficient burn. This crazy level of control also lets the ECU do some really slick stuff. Instead of just one big squirt of fuel, it can command multiple little injections in a single power stroke. There's a tiny pilot injection right before the main one that smooths everything out, which is what makes modern diesels so much quieter than the old ones. Then you get the main shot for power. And there can even be a post-injection afterwards to help burn off soot in the emission system. It's just brilliant. Okay, so what does all of this incredible technology actually mean for you, the driver? Let's put some real-world numbers on it. On a popular modern diesel truck right from the factory, the stock pressure is 29,000 pounds per square inch. I mean, that is just an immense amount of force. It's already pushing the limits of material science. But, it never stops there. With some careful tuning and the right parts, performance experts can safely push that system even higher. Bumping the pressure up to 35,000 psi lets them get more fuel into that same critical injection window, which unlocks a ton of extra power without creating a bunch of smoke. And this brings us right back to that paradox we started with. By intelligently controlling and increasing that rail pressure, you get more power when you floor it, but you don't sacrifice that smooth, efficient drivability for the other 99% of the time you're driving. It really is a rare win-win in the performance world. Think about it. Wind went from 23,000 psi a few years ago to 29,000 stock today, with tuners pushing 35,000 and even more. We are talking about pressures so high that they're used in industrial machines to cut steel with water jets. So it just leaves you with this fascinating question. What are the ultimate limits here? How much higher can this technology possibly go? And what new levels of power and efficiency is the next generation going to unlock?